Hey guys, what's up? There's Daniel Tiger going on in the background here, so you're gonna have to try to tune that out. And I should probably turn it down. It's like real loud, real loud. Ow! Okay, there we go. So
Hey, I can hear it.
you can still hear it. You're fine. You guys, I totally understand the struggle of like trying to do all of this and whatnot, like at home, because like I'm trying to do this with Henry. Like I totally get it when you guys like get stuff done late or like turn things in a day after. Like it's cool, all right? I just want to walk through what this assignment is because this is new and this is a new topic. So the other day, you were introduced to Goldilocks and the Three Bears, or you were just reminded of Goldilocks and the Three Bears. And so in that story, remember, Goldilocks goes in and she picks all of the things that are just right, okay? And so they have named the habitable zone also the Goldilocks zone because it's a spot where a planet is just right. And if it's just right, then it can have liquid water. If it's frozen water, that's no good. If it is water vapor, so it's in the atmosphere, that's no good either. We need liquid water on the surface of the planet in order for scientists to consider it possibly habitable. So when we're looking at this worksheet here, I'm going to be scrolling over on this. So the just right, or Goldilocks conditions for life to have liquid water, first they want primarily, they're looking at sun-like stars. So if it is an FG or K star, and that distance then would be 0.84 AU and 1.7 AU, okay? Now, if you go down here with me real quick to this, if a star is right here where I'm pointing, F, G, or K, then we're looking at 0.84 to 1.7 astronomical units. That's how far away the planet needs to be. If this star was an M star, okay? If it's an M star, it's cooler. So then we want the planet to be closer to that cooler star. So instead of 0.84 to 1.7, it would probably be like 1 point something to 2 or 3 point something, depending on where this temperature actually sits. The cooler the star, the closer the planet wants to be or can be. And then the next one is these high stars. So if these are really, really, really high temperature, these are really high temperature stars, then the planet needs to be further away. Because if we have an O star that's 30 to 60,000 degrees, and we're 1.5 atmospheric or astronomical units away from that star, like everything is just going to burn up, you know? It's not going to be a habitable planet. It needs to be far enough away that the amount of heat that's actually reaching it is just enough where the water's not going to freeze and the water's not going to evaporate. It's going to be liquid, okay? So we're going to focus mostly on the F, G, and K stars that are in that habitable zone of 0.84 to 1.7, okay? But if you're looking at the M, we need it to be closer. And if we're looking at O, B, or A, it needs to be further. The other thing, though, we don't just want that one distance because there's other things that we're going to need. It has to have a suitable atmosphere. So there's two things that are going to help us get a suitable atmosphere, and that's the mass and radius of the planet, okay? So we're looking for, again, with these, the FGK stars is also a mass between 0.5 and 10 Earth masses, because that size will help to pull in a certain amount of atmosphere, not let too much of it escape, but not pull everything in. And then a radius between 0.8 and 2.2 times that of the Earth. Those two requirements there will balance out that we'll get a nice atmosphere around it where we're not going to have the crazy greenhouse effect that happens on like Venus where it gets so hot and then not habitable. And then we don't want something where the atmosphere is so thin like Mars where nothing stays in, okay? So we're looking at those requirements. So I highlighted those things, sun-like star, have the habitable zone, the mass, and the radius down in this chart here. Because what you're going to be doing is you're going to go through all of those planets and you're going to say, should I go search there? Should scientists go search there? So I did this first one for you, Governor. So the planet Governor is around an A-type star. So A-type stars are hotter, okay? So remember, we want to be further away. But this says it's a distance of 0.05. Now remember, our astronomical unit that we want is 0.84 to 1.7. So this is super close. It's also super big, okay? And then the radius, we only want it to be like 0.8 to 2. So this is super big. This is a really big planet that's really close to a hot star. So then down here, what I'm going to say, first I'm going to say do not search, okay? And so this planet is 0.05 AUs from an A-type star that's hotter than the sun. So it's too close, too hot, okay? I don't even have to talk about the size and the radius because it's too close and too hot. That just rules it out right away. So then you'll go on to the next one. So you'll go to Wells and you'll look at that and you'll say, okay, B-type star. Reference up here, B-type star. Okay, this is really hot, 0.75. Is that too close? Is that too far? What about the mass and the radius? Where are those sitting? Because some things might work, but some things might not. So you have to figure out what you should. Sometimes you might be like, maybe this would work, and you can put that. You can say maybe it would, but it might be just a little too close. So there's a range there. So you guys will have a few days to get this filled out. If you get it done on like the first day, those next days you'll just log in basically for attendance questions because you already have your assignment complete. So yeah, let me know if you guys have questions or anything. And miss you all.